Okay. My project is the effective cooling rate on the recrystallization process of magnesium sulfate. My name is Daniel Shenko, and I'm in 6th grade in Putnam Avenue Upper School. I'm fascinated with geometric shapes and shapes in nature, for example, snowflakes. That's why I've researched how various conditions impact the growth of crystals. Crystallization is a process that forms crystals, highly organized atoms or molecules. Magnesium sulfate is a naturally occurring mineral used to control low blood levels of magnesium. The methods and materials we used to test our hypothesis were magnesium sulfate, 3 cups, a heater, a fridge and freezer, and a scale. The procedure we used was to add salt to water, then to boil it, then to add more to get a saturated solution, then to fill 3 cups. Then we put the cups in various temperatures, one in room temperature, the second in fridge, and the third in freezer. Then we added a seed crystal to every cup. Then we measured the growth of all the crystals. The variables we used were the independent variable, the temperature of the cooling process. The dependent variable was the size of the final crystals and their growth rate, and the controlled variable was the shape of the crystals. In experiment 1, we used an oversaturated mixture. The result of the experiment 1 was that cooling intensifies the growth, and that it's hard to compare sizes and shapes because growth is too intensive because of oversaturation. In experiment 2, we used an undersaturated solution and longer cooling. The result of our experiment was that our cold temperature and smaller size needle shaped, and that boosting cooling makes larger size crystals. In experiment 3, we used an undersaturated solution with a seed crystal and cooling. The result of our experiment was that cold temperature makes smaller size needle-shaped crystals, and that boosting cooling makes larger sized crystals. And here are the pictures for experiment 3. Our conclusion and recommendations are that low temperature significantly facilitated the growth of crystals, and that mass and volume of crystals in cup 2, the fridge, is significantly larger than in cup 1 and 3. And that low temperature impacts the size of crystals because they become smaller. And that a high cooling rate in the fridge for 15 minutes fosters growth of large crystals. For these next experiments, I would like for the crystals of mass should be measured. These are references. Almost all of them are from Wikipedia and one from cyrus.com.